afternoon, everyone. A very warm welcome to everyone present here this afternoon. My name is Anshu Ranjan. Today, I will be speaking on the behalf of SPE IIT ISM student chapter. Before starting the session, I would request all the attendees to mute themselves. You can type your queries in the chat box or can unmute at the end of the session. All attendees will be provided a participation certificate at the end of the 2 days webinar. So make sure to ride along this journey.
Okay, thank you, Anshu. I would like to speak a few lines about the topic of the session today. So, machine learning, we all know about it, right? We have heard about it. It's making waves in the industry. We have seen ads about it, like hundreds of courses popping up in premier institutes across the globe. But what is machine learning in general? It's in simple words, we feed process data to a model, a machine learning model, and the model processes the data and predicts the outcome. It's a very simple definition. There are, of course, much more complex aspects associated with it, and constant research is being happening. But the important thing that we are gathered here today is that machine learning is the newest wave in technology. Now, what do I mean by waves in technology? Like you have seen in the past, like empires like Microsoft and Google. What are they? They were people who were smart enough to harvest the newest wave of technology. Like when OS showed up, Steve Jobs and Bill Gates harvested it. When search engine showed up, Google harvested it. And in the recent years, like delivery apps and cabs for hire, companies like Uber and Ola harvested and created multi-billion-dollar empires. These older corporations are, of course, researching machine learning, but newer corporations are, of course, popping up. You may have heard that the youngest self-made billionaire is actually a machine learning engineer. He's a Chinese-American man. He's the founder of SPE AI. The name probably says it all. It's a machine learning and data science startup. But we are not gathered here to look at the financial and, of course, the massive success associated with machine learning. We are looking at the fundamentals of machine learning and how it affects the oil and gas industry. And like all industry, machine learning has found its way in this industry too. And we have Mr. Divyanshu Vyas with us to guide us along this way. And I'll pass on to Anshu Ranjan to give a small introduction about Mr. Sir and the session in general. Over to you, Anshu.
SPE IIT ISM student chapter brings to your workshop on the fundamentals of machine learning by Mr. Divyanshu Vyas. Mr. Vyas currently holds the position of data scientist at Accenture Applied Intelligence. Apart from that, he is also the founder of Petroleum From Scratch. Needless to say, he is a man with experience, and his previous experiences include working as a machine learning and data analyst consultant, oil and energy projects, and a community mentor for Python and data sciences for the oil industry. This today workshop will cover topics like basis of Python for oil and gas, data analysis crash course, and visualization crash course. So, ladies and gentlemen, please put your hand together for our guest, Mr. Divyanshu Vyas. Welcome, sir.
Thanks, Anshu. Thanks, guys. Thanks, everyone, for attending. I know it's a Saturday. It's already a win if you are in the session, because who wants to learn on Saturdays is someone who's enthusiastic enough about doing something. So congratulations on joining the course. Thanks for the warm introduction, and thanks for a quick heads up about machine learning. Thanks, both of you. So we are happy to start the session, I guess, or are we waiting? Guys?
So we are ready.
Okay.
We are going to start, sir.
Your video is off.
Yeah.
Yes, sir. Please switch on your video.
I'm not like in my area. It's raining a lot, so if I turn the video on, it will maybe lead to problems. So let's keep the video.
No problem.
Yep. Okay. So just because I told you about the rains, if in case I go off for a couple of seconds, just wait and I'll be back. I might have to switch my internet. So don't worry about that. All right. Just a quick heads up. Okay, starting. All right. So today's session, I won't be giving you much of the motivation, as I guess all of you are here because you are motivated enough to learn about machine learning and data analytics in oil and gas. We all know the hype is real, and the hype is for a reason. The hype about machine learning and data sciences is because now industries are realizing that, hey, a lot of data is being accumulated. And industries are now realizing the potential that these accumulations of data can generate. But you will counter my question with the fact that data was there in the back in days as well. Yes, the volume is increasing, but what has come in is the huge computational powers that joins us together to the world of machine learning. For example, every one of us 2 years, 3 years back, we would not have been imagining a session happening so easily on a platform like Google Meet or Zoom or whatever. But this is now becoming very easy. The reason is because everyone now has computers. Technology is now becoming more and more accessible. So everyone has a computer or a laptop or at least a smartphone. So they can attend sessions, they can learn things, everyone can grow in this field. So that's the first victory that we can target at. No matter what laptop you have, no matter what kind of, I know like most of you might be in your undergrad school and you might be still thinking about, hey, what laptop should I buy? I remember back when I was in first years and second years of my bachelor's, for the first year, I guess I did not have a laptop at all. And that was the initial days. But now people are thinking about getting not just a laptop, but getting good laptops so that they can work on it. Even if you don't have a brilliant laptop, there are ways you can practice data science and machine learning. So everyone can hop onto their Gmail accounts and they can search about Google Colab, and you can code whatever I'm teaching today. You can code hands-on on Google Colab. You don't have to install anything. But if in case you have some installations already done, that's well and good. You can install something. So the message from my side is, no matter what your situation is, no matter how your laptop is, no matter, even if you don't have a laptop, if you are attending it from a phone, you will receive the code notebook after this session. You will receive the link to the repositories. You can borrow someone's laptop and just practice. So this is a course for absolutely everyone. So this is a course in which we will learn things hands-on. We will look at technologies. We will look at Python programming, but with a pinch of oil and gas examples, so that we get connected to our own industry every now and then when we understand a concept. So I'll share my screen now and let me know once it is visible, and we will start with the hands-on tutorial. You can take 1-2 minutes, everyone, if you can open a Google Colab note. If you are following along with the session and you want to practice along with me, you can open Google Colab notebook, or you can open a Jupyter notebook in your own systems. I'm assuming you might have installed something. If you don't have a Jupyter notebook installed, you can open a Google Colab. So I'll type in the chat what Google Colab is. I see that someone's asking, is the session being recorded? What's the status? Are we streaming?
Yes, sir. It is. Yes, sir. The session is being recorded and it is streaming also in the YouTube on our YouTube channel.
Perfect. Okay. All right. So I'll share my screen. Let me know once it is visible, and we will start with the hands-on. Do you see the day one? Can you see it?
Yes, sir.
Yes, sir. It is visible.
All right. Brilliant. Okay. All right. So day one. So like I promised, today we will not waste any more time on the motivations and the philosophies and all. We'll directly start with what's the basic. The aim of the workshop is to get better and get a hands-on with machine learning. But we cannot directly jump onto machine learning. We want to develop a gradual path towards becoming a data scientist or a machine learning engineer. And for that, we have to learn a few tools. So the workflow, I'll be providing this notebook to you after this session. So don't worry about that. Workflow will be, you'll first learn Python, basics and syntax, right? You will get familiarity on what Python is. I mean, you will get familiarity with what this coding environment is, right? I'm assuming everyone has downloaded and opened this Jupyter notebook at least once in their lives. Or if not, I've written in the chat about Google Colab. You can open a new notebook in Google Colab and do the same thing I'm doing right here, right? So today we will look at Python, and then we will look at like basic Python, and then we will look at NumPy and Pandas. For what? For dealing with data. Do you want me to zoom in? Anyone? Please let me know, because once I'm coding, I cannot see the chat boxes. So the hosts, you can, anyone who's hosting the session, you can unmute and bring me the audience's request, right? Okay, so the second step will be NumPy and Pandas, and then we will have visualizations. And then we will have examples. Okay, so this is going to be what we will be looking at today, right? So let's start with it. Python is something that I suggest learning to everyone. Some people, they want to learn R, but R and Python, I think they are almost equally good in terms of machine learning connections they have. So both of these programming languages, they have their own pre-built machine learning packages. So for example, you can code a regression problem, linear regression problem, using basic Python as well. You can code a formula using basic Python as well. But what about you create a function of that formula and use the same function every now and then? That reduces the number of lines of code. So Python has a lot of such packages and functions for machine learning. Similarly, R also has. I find Python more interesting and more easy to understand, and you can connect with Python and get on speed really quickly. So that's why I always support Python, and I've always worked on Python. So if you ever want to ask anything from me, I would always answer things in Python. So Python is the programming language we're looking at, but you can also try exploring R as well. So there's no issue. All right, so let's start with Python now. Okay, Python crash course, let's call it that. So in Python, there are a few data types. So let's wait for that. But let's see how can we print something in Python. Okay. So printing something in Python. Print. Hey, I am in IIT ISM. Okay. So this is how you print. This is how easy it is. You will find every syntax is as if we are talking to the computer. So hey, computer, print something, right? What if you want to add two numbers? 2 plus 3. What if you want to multiply two numbers? 2 multiplied by 3. What if you want to divide two numbers? 4 divided by 2. Okay. So you have to provide a comma to print two numbers. You can see 2 multiplied by 3 is 6, but 4 divided by 2 is 2.0. So default interpretation of Python is this is called a floating point number, and this is called a integer. Okay, so there are two data types. So if I do the type of the number 2 multiplied by 3, if I check the type of this number, this will be integer, right? But if I okay, can you see my screen?
Yes, it is visible now.
All right. Let's get back. We printed a statement. We added two numbers. We looked at how to multiply and divide. Everything is as you do it in a calculator or something like that, right? Then we check the type of a number. You can check the type of various kind of data types in Python. So there are various kind of data types. You can see 3.3 to 6.0 is a float. 3 is an int. If I type my name, it will be a string, right? So there are various kind of data types. These are the most popular data types: float, int, string, right? And in the coming 5-10 minutes, we'll look at other data types. But to check the type, the syntax remains the same: 1, 2, 3. This is a list of numbers. So if you print the type of this, it is a list, right? And there are other data types like a set, right? A set is other kind of list in number, but the repetitions are not allowed in a set. It is closed by curly braces. So if you check the type of this, you can see the type of this is a set, right? And so on. There are other data types like a dictionary as well. Type of a dictionary. A dictionary is something like a word dot its meaning. right? To keep it very similar to the word dictionary. So to check the type of this entire thing, you can see the type is dict now. Okay. So these are a few data types in Python, and there are different ways of storing numbers or assigning numbers to various variables, right? So this is about the basic stuff in Python. This is about how to calculate stuff in Python. I told you there are two kinds of divisions. What if you want to check if I divide 5 by 2, what is the remainder of this division? So the way to do that is you use the percentage sign, and this is called the modulo operator. And you can see the number is 1. When you divide 5 by 2, the number is 1. When you divide 9 by 3, the remainder should be 0. So this is the modulo operator. So this was the first topic. This was what? This was data types. Data types and simple computations. Okay. Next up is we will look at variables. Now, it does not make sense to have just these computations and not store these in a variable, right? In math also, if you are doing some calculus or any algebra or anything, you assign something that Q equals to 5,000 barrels per day, mu equals to 100 centipoise or something like that. So you always want to store, if you have a value, you want to store it in a variable. So there are certain rules in Python about variables assignment. So the second topic here is variable assignment. Okay. So for variables, I'll give you an example right away. So x123 is allowed, but 123x is not allowed. X $123 not allowed. Okay. So this is a valid variable name. Underscore is the only special character which is allowed in a variable name. The variable should start with a letter or an underscore. It should never start with or include a special character other than an underscore. It should never start with a number as well. So that's the simple story behind variable namings. So I'll give you an example. X1 is equals to 300. So you can see this is allowed. But if I try the same thing with 1x equals to 200, that's not allowed, because right away Python is giving me a green color for this, which means Python interprets this as some predefined data type. It's not a variable name. Anything which you are creating, anything which is the user's creation, which is a variable, will be always in a black color. So you can see the black color, but right here you can see 1 is in green, which makes it a bad candidate for a variable name. So you cannot use something like this. So I'll give you another example. X_12 is allowed, but when I run it, oh, by the way, if you want to run a cell, you have to press Shift plus Enter together, right? But if I use X$12, you can see dollar is giving me a red color, which means this is not allowed. It is telling me that this is invalid syntax. The benefit of using variables is I can be like K equals to 100 millidarcies, or let's say 1000 millidarcies. A equals to let's say 200 feet square. Ka del p is equals to 10. Mu equals to 100. L equals to 10,000. I'm taking random numbers. So this is, you might have guessed, this is a Darcy's law formulation. So Q can be calculated by simple computations. K A del P by mu multiplied by L. So you can see now I can calculate this and I can print the value of Q. So this is the benefit of having variable assignment. So you can use the same formula again, but now what if someone tells me that, hey, your value of delta P was incorrect. You have to have 100 psi delta P. So you can replace this with 100. You can run the same command again. You can replace this with 1,000. You can run the same command again. You can say that, hey, this is another reservoir with a lesser permeability. You can remove 2 zeros now, and you can see the flow rate now reduces. So you can see intuitively you are understanding the things better now. What if I vary the viscosity? If my oil viscosity is higher, will there be a change in flow rate? Let's see. You can see the flow rate has reduced to 0.2, which means which is a reservoir engineering concept, right? Because if the oil is very viscous, it might be facing a lot of friction when it's flowing. It will not reach the wellbore that much with with a good amount of pressure, which means a flow rate will be reduced, because lighter the fluid, higher the flow rate is. For example, if I reduce the viscosity to 0.1, see 2000 barrels per day is, or whatever units, this is not in SI, like it is not in field units, but the unit value at increased to 2000 barrels or whatever. So you can see that's the difference. That's the benefit of using things in Python. I mean, if you were doing it in hands on paper, you would have to calculate every now and then, but now you can just plug and play, right? If I increase now this is a very less common factor. No one knows the impact of area on the flow rate. Let's vary the area now with the same parameters. It reduces the flow rate, right? So that's a few examples of variable assignment. Now let's look at asking for user input. This is where Python starts feeling like more connected with the user. What if, rather than doing all this hard coding them, what if I wanted to print a box kind of thing where the user can enter their values and the final calculation will be updated accordingly? So if I copy this here and I paste it here and I replace this, all I have to do is, now let me give you an introduction about the input statement. So name equals to input, enter your name. When I do this, when I run this cell, you will see that it will ask me for a message. It will ask me to input some value. Okay. So you can see enter your name. So if I write Divyanshu now, you can see my name is, now whatever value you enter here, it is stored as a value of this entire thing, and it's stored in the name variable. Always remember, guys, in Python, whatever value is created on the right hand side gets assigned to the variable name on the left hand side. This equal to sign is assignment. This is not equals to, this is assignment. So there are two things in Python. One is equals to, which is assignment, and one is double equals to, which is comparison. So if you want to compare whether two numbers are equal to each other, you will use the double equals to sign. When you want to see that you want to assign some value to a variable, you will use a single equals to sign. Okay, so this is assignment and comparison. Okay, now I'll tell you one problem with the input statement. So let's say x equals to input, enter a number. Okay, when I press shift plus enter, and let me also print x, or let me not print it, but just give it like this. Okay, n. Let me use the print in the next cell. Okay. Okay, let's keep it like that. Okay, enter a number. I give it 500. So in these two cells, I will ask this to the audience. In these two cells, do you spot a problem? Let me see if you can find it out. I've asked the user for a number, and the number is displayed here. Do you see a problem?
Yes, this is in a string format.
Exactly. What's your name? Whoever answered.
Ajay.
Okay, thanks very much. Yeah, exactly. So we are expecting a number, but by default, the input statement accepts things in the format of a string. So yes, you are entering 500, but these quotation marks that you see around 500, they tell you that the value that is assigned after input is a string. So you have to do something which is called typecasting. You have to repeat the same thing with some additional steps. Okay, you have to convert it to, let's say, a float. You convert it, you provide a float function outside it, so that when the user input is taken at here, whatever value is stored in here, it's changed to a float first, and then it is assigned to x. Okay, it's very easy to understand. So now if I do this 500, and now if I print X again, you can see 500.0. Why this 0.0 is coming is because this is float. Now if I repeat it with int 500.25, first it will give me an error that, hey, integers cannot accept this thing. Okay, you cannot, because this is a string with a dot as a special character. How can you ask Python to convert it to a string, right? So you have to use a float here, or maybe input valid number. So 500, if you enter, it is allowing it. Now you can see the dot zero has been removed. So it's a very important command. I mean, even if you write complex algorithms, there will be some parts of your code where you will be like, it would be better if I provide an input statement here so that the code stops at this point, waits for the user input, and then proceeds only after I provide the user input. Okay, so that's why these input statements are very handy. Now, I mean, I can ask the user, for example, I'm creating an experiment on permeability's effect on flow rate. Now I can add an input statement here, right? Input, enter permeability in millidarcies, and it will be converted to a floating point number, and finally the result will be to print. Now I'll introduce one more step here. Now but yeah, I'll introduce in the next step, don't worry, because it will be too complicated in one cell. Now if I run the same cell, you can see it will wait for me to enter any value first, then only it will execute the remainder of the code. So that's the benefit. I mean, the Python interpreter will not continue unless and until I provide the input statement. So there'll be a lot of cases where you want the program to wait before any other steps are created. For example, in order to read an email, you have to first log into Gmail. You can never proceed to reading your emails if you are not logged in. So the Google team has set up such a procedure that if user provides some email address in the text box, then only next steps will be carried out. Similarly, for permeability, for flow rate calculation, it is a must to have permeability, and that's why I won't calculate flow rate until and unless permeability is provided to me. So I'll provide permeability here 500 millidarcies. We can see finally the flow rate is printed. Okay, so this is about the input statement. Okay, we are gathering concepts one by one. Let me introduce another concept: how to print variables in the print statement. Okay, now suppose I did not want to print like this. I wanted to print a statement that, hey, your flow rate for this permeability value is this much. So I have variables that have permeability, and I have variables that have both flow rate and permeability. So ideally, I would like to do this, right? Print A for permeability equals to K. The flow rate is Q. Okay. Now, remember, I'm using the same variable as I'm storing it here. Okay. But tell me your guesses, guys. Will it run? Or what will be the output of it? Will it store the value of K, or will the K as a letter will be printed? The guess should be K as a letter will be printed if I run it. Yeah. So you can see it's not interpreting, because how will Python understand? Because for Python, this is a sentence. How can Python understand that the user wants to print not just the letter K, but the user wants me to print the value of K, whatever K is storing inside it, right? So there's just a small edit you want to make to this. Paste the same command again, add a F against it. I repeat, so this is the entire string. You add a F against it, okay? Now, wherever you want the value to be printed and not the variable, you provide curly braces around it. And I told you, right, if something is your creation, K as a variable name is your creation, Python will print it in black. So you see the color has changed. Now, if I print it again, hey, for perm equals to 500, the flow rate is 5000. So you see the small change has created a huge difference, and the syntax remains very, very compact. So this is called, in Python, this is called F strings. Okay, is everything clear? I'll take 2-minute pause to see any doubts till this point, and then we will move ahead. I want you to grasp absolutely everything that I'm talking about right now. Okay, I'm going from very, very zero, and then we will take it gradually upwards, right? So please hop in with your doubts in the chat. I'm taking a 2-minute pause to see for any doubts. I see no doubts in the chat. What is the meaning of F? Because if you add a F against the string, and then for every variable name that in the screen that you see, adding of F makes sure that Python understands that this is a formatted string and not a normal string. Python will understand that whatever is going to come inside the string here can have variable names inside it. So it's a way of making Python ready for something. So when you provide F, Python is ready that I can expect variable names inside the string, and I have to print the value of the variable, not the letter of the variable, right? So if you do not provide F and you do not provide the curly braces, you will see the letters of the variables are printed, K and Q. But if you provide F and the curly braces, 500.0, 5000.0, the values are printed. Are there other similar prefixes like F? Yes, there is a prefix R, which reads a string like a raw string. It is useful when you are reading paths from various websites, but that's not the topic for now. But R is another prefix like that. Nikita is asking, sir, in the print statement, we can print even without using F strings by using commas. Yes, we can. But I like, because the readability is important. Nikita has raised a good point. So what I've done here, you can do something like this as well. Control C, Control V. So if I remove the string, F string, hey, the perm is, I can end the string here. Okay, I can end the string here. I can add a comma here. Okay. And let me see, I'm not a big fan of this approach, but let's see. Because this breaks the readability, right? This breaks the readability of the entire statement due to additional commas. Okay, so I think this is also something that works. Yep, this is what Nikita is saying in the chat. You can ignore the using of F. Hey, the perm is, end the string here, comma K. The flow rate is, end the string here, comma Q. So this is also possible. A lot of ways of doing the same thing, different ways of doing the same thing. Thanks, Nikita, for this. But yeah, I like F strings better because this maintains the integrity of the sentence. But good enough, good that suggestions are made. Okay, any other doubts? Are we clear till the point where we assign variables? What are the rules of various variable namings? What are the, how to add two numbers, how to subtract two numbers, simple stuff in Python. So by now you are familiar with the Python environment, and I hope you can do the same on your environment as well. Okay, so we will move ahead and we will see what is next for us. Let's see what is next for us. Okay, we already looked at variable assignment and strings and all. We looked at printing. Okay, now let's look at one by one data type, detailed data types. Okay, let's look at dealing with strings. Okay, there'll be a lot of cases. For example, my full name, if I store it in a variable, Divyanshu space Vyas. This is my full name. Now, what if I want to use the same value and, so let's add this inside a input statement. Enter your full name. Okay. The user will enter a full name, and the aim is we want to split the name into first name and last name. How can we do that in Python? So that's the first step. So enter your full name. It is Divyanshu space Vyas. Okay. So full name here is Divyanshu space Vyas. Now in Python there is a split command, split for strings. So for if I do this full name dot split, I can provide a splitting condition. I want to split the name on the basis of a space. Okay. So if I press this, you can see the names components are split on the basis of the breaking point. Here our breaking point is a space, and every element is stored as a different value of the string. And if I pick up the first element, which is the 0th element, I can pick up the first name. Okay. So this is my first name. Similarly, the last name is the same splitting thing, but the second element. Now we are going a bit advanced, okay? Last name. Okay. Now if I print the first and the last name, okay, Divyanshu space Vyas. Okay. So these are two separate print statements, guys. Don't get confused that why are you printing the same name again. You can see Divyanshu and Vyas. Okay. So if I enter another name, for example, like right now Nikita talked to us. So Nikita Sharma. So if I use that name, Nikita Sharma, first name, last name. So this is clear. This is how you, I'll talk about indexing. This is called indexing the first element. This is how you extract elements from a data type. But this is a simple example of a split command. Another example is indexing of strings, okay? Indexing and slicing of strings. Okay? So let's use the same full name again. Okay, we have a full name called Nikita. So every element will have a different different index position. It's like a roll number. Every character has a roll number. The letter N is at the 0th position in the string. Okay, so letter N is at the 0th, I is at first, K is second, I is again at third, so on, right? You can also start indexing from the last. The last element is minus 1th element, then -2. It's like starting and going leftwards on the x-axis, -1, -2. So if I print full name 0, we can see N. Full name 1, K. Full name 1, K. I. So NI. You can see the roll number, the element number 2 is located at an index number 2 minus 1, because indexing in Python starts at 0. I'll write this here. Very important. Indexing in Python starts at 0. Okay. So if I want to print the first element, I have to provide the index number 0. I'll repeat this because people forget this, and this leads to a lot of errors. First element is located at 0th index. Let me write it as well, because this is going to be your notebook for this session. First element is at 0th index. Okay. Now I'll give you an exercise, but let me give you a slicing example first. Okay, slicing example first. So the question here is how to slice the string so that we can print the first 5 letters. Okay, so the string is full name. We want to print the first 5 letters. So the idea here is syntax is, if S is your string, you start with the starting index. Let me use this thing. String, or let's say full name, start, stop, and step. I'll explain what I mean by this, okay? Full name, start, stop, step, okay? So full name we have. Starting index is 0 because we want to print the first 5 letters. So the first element has to be printed. It is included. The stopping element has to be 5. So because 5 will not be included, so it will be at till 5. And step will be, if you don't provide step, it will pick every element. I'll tell you the difference of how a step creates, right? So you can see Nikit is printed 1, 2, 3, 4, 5. Okay, so you'll see, you have to observe something here. The fourth index is not, like the fifth index is not included. So the starting index is included, n is included, but the fifth index is not included. Remember guys, this is not the fifth index. This is the fifth element, which is the fourth index, right? So always remember, the starting index is included, stopping index is not included, and we will see the difference of step here. Okay, so here there's no step here, but if I use a step size of 1, let's see, it is the same thing, Nikit, but if I use the step size of 2, it will print alternate elements. It's like a jump. Every second element is printed. So this statement, what does it mean? This statement means pick up the full name, start with the 0th index, end at the 5th index, don't include the 5th index, which means include the 4th index, and pick up every second element. I'll repeat. Take the full name, start at the 0th index, end at the 5th index, do not include the 5th index, which means include the 4th index, and take every second element. So you can see n is printed, which is the 0th index, 0 is included. Then 1th index is excluded, k is included, you can see k is here. Then I is excluded, and then t is printed, you can see t is here. Then we reach the extent beyond this, that's why that section is not printed. The very common application is checking for a palindrome. Everyone knows what a palindrome is? Any Naman in here in this webinar? Anyone whose name is a palindrome? Palindrome is something like a Naman. If you look at it from the front or from the back, the name is the same. A number like 1, 2, 3, 2, 1. Starting with 1, 2, 3 or starting from the end, they are the same things. Okay? So it's a very common programming example. You want to write a program that checks whether a text is a palindrome or not. Okay, so let's do it. So we'll have to reverse the string to do that. Okay, so if my string is Divyanshu, or let's say porosity, this is my string. How to reverse the string? We start with the last element, which is minus 1th element. We stop at the 0th index, which means if you type 0 like this, it will not include the 0th element, which is not what we want. So we want to keep it the default. And the step size will be, what is the step size? It will be minus 1, because we are going in the opposite direction. You can see by P. So if you look at it, this is the reverse of porosity. And how will you check whether this is a palindrome or not? You will compare. So this is the reverse string, reverse text. Now I will compare the reverse text equals to, I will use double equals to. I told you double equals to means comparison. I'll check reverse text, is it equals to text? False. But if I replace it with Naman now, Naman, true. So this is how easy it is to check a palindrome in Python. So is it clear how to process strings? Indexing and slicing, very important. How to split a name, common manipulations with strings. There are other methods as well. So if you use a string variable and provide dot and tab, you will see a lot of things that you can do with strings. These are called methods that you can apply to a string. For example, full name dot upper. You can see Nikita is now in upper cases. Full name dot lower, you can see Nikita is in lower cases, right? So For example, I wanted a program to be robust enough so that even if I provide numan like this, because numan in itself is a palindrome, I don't want it to be case sensitive. So what I can do is I can apply a processing step text equals to text dot lower. I can convert it to a lower case first and then apply. You can see now it's 2. But if I did not apply this, it will give me false because by default it is case sensitive, right? So a lot of methods can be applied, default methods can be applied to a string. So you can check yourself out. But this is the basic things that you must know about a string. All good? Any doubts in the chat? Why didn't we mention stop number? Shoaib, you can try this out. If you provide the stopping point element, that will be excluded. I told you it's not included, right? So if you are starting from -1, either you end till let's say let's do one thing, okay? Let's do one thing. So Nikita is A is -1, -2, -3, -4, -5, -6, -7, -8, -9, -10, -11, -12, -13. So if you want to provide the ending index, provide -14 as the ending index because -13 is the last element. But a shortcut is to not provide anything. Python automatically understands that the user wants to include the entire sequence starting from this element. So I hope that was clear. Any doubt in the string part of the session? I'll take 1 minute to drink some water and we will get back to talking about lists and tuples after this. Okay. We'll carry on the session and complete the Python part of things and then we will look at NumPy, Pandas, etc. Right. Nikita says that if we did not mention starting and stopping, only step -1, then will the same thing be printed? Let me imagine first. So you are saying that you are not telling Python where to start from, where to end at, and just provide a step. Ideally, it should not work because ideally by default, Python assumes you are at the first element. But let's see what comes out. Let's see that. Okay. Full name, what Nikita is saying is that full name, start and stop is excluded and we just provide a step. Brilliant. I think Nikita knows a few things in Python. So Python, but the way it is compiled is different in this case. So the way it is compiled is Python starts at 0th element and then it sees that there is no starting and stopping, but step is -1. So it goes back because if you go -1 step from N, you will land at A. And that's something that will continue. But if you provide -1 at the starting index, Python has one less step to complete. So I hope you understand. The output will be the same, but Python is by default it is at N. If you provide it nothing, it is by default at N. Then it understands that okay, -1 step. So from N it goes to A, and then everything is printed. But if you provide a starting index as -1, then Python starts at -1 and it prints the whole thing. Yes, so the output is the same, but one step less. Good stuff, Nikita. So any other doubts? All right, looks like no further doubts. Let's move on. Let's move on with the next part. We will now look at lists. Okay, a list is to store a set of values. Okay, my porosities is equals to 0.23, 0.25, 24, 0.10, maybe a carbonate, 0.43, 0.26, something like that. Okay, so this is the application of a list. Okay, but not just this. I can have a bag of values, of reservoir values. I can have porosity, 0.25, 223, whatever. Permeability, 200 millidarcies, right? This is also possible. Okay, so this is about a list. If you want to check the type of this, you can check the type of my porosities. It's a list. Okay, so that's a good thing. You can check the type always. Okay, the good thing is it allows you to store a lot of numbers and values under one bucket. The bad thing is what? Bad thing is it is very slow. The bad thing about list is it is very slow. I mean, if you do computations on the list, it will be very slow. For example, what if you wanted to square something, my porosities to the power 2? It gives you an error. You cannot directly square something like that, right? So you always have to be very considerate about calculations using a list. Python is not very happy when you apply calculations to a list. Python assumes that a list is just for storing things. The user does not intend to do computations on the storage. Okay, so that's about a list. List can also be indexed and stuff like that. Okay, so my numbers like my porosities is this. So what if I wanted to print starting from the first to the end, my porosities starting from 0th index up to the end index, okay, and a step of 1. You can see the whole string is printed again, list is printed again, 0 starting at 0 ending at 3. This is a slice of the list. Okay, again step of 2. You can also reverse the string like that. Let's use Nikita's way of doing things. You can see the string, the list is reversed now. Okay, what if you wanted to add one more value to the end of the list? Append is the method to do that. Append, what it does is it adds something to the tail of the list. Okay, so my porosities dot append 0. Let's add a random value. So you can see if you print my porosities now, you will see this 1000 is added. So if you do my porosities dot pop, it's like it pops out one element from the list, and the list will not have that value again. So you can see append and pop, they are like opposites of each other. Append ends things to the last point, pop removes things from the last point. Okay, so my porosities -1 is this. Okay, now let me introduce something. Mutability versus immutability. Mutability means nothing but it's like modifiability. I'm making my own word here. Modifiability. You can modify a list. List is mutable. But tuple is immutable. Okay? A list is mutable, but a tuple is immutable. And that's, we will see what immutable is when, and a string is immutable as well. Let's see what I mean by that. Okay, my porosities is here. Okay, suppose I change my porosities, I want to append 10% porosities to it. Okay, I append it like this. Okay, append it like this. And when I see my porosities again, my supervisor sees this, right? My professor sees this, and he's very angry at me, rightly, because the entire set of porosities is in fraction. Why are you using percentage now? So what you want is, you want to, change only this element of the list to 0.10. So my porosity is -1 is equals to 0.10. You understand what I'm doing here? I'm picking up the -1th. So every element, every index of the list is a separate variable in itself. So I am picking up the last element variable like this, and I'm assigning 0.10 to it. Okay, I'm assigning 0.10 to it, and now when I do this, my porosities, you can see 0.1 is now there. So this is called mutability because I could edit the contents of a list. Now, what if my full name variable, what if I wanted to, with no offense to Nikita's actual name, I wanted to add a exclamation mark at the end, let's say. Instead of A, I wanted to add an exclamation mark, okay? Or maybe add one more A or something like that, maybe, okay? So something like that I want to do. How can I do that? Okay. So full name -1, same thing. I want to replace the last element with not this one, but maybe a capital A. It gives me an error. It says that string object does not support item assignment. What does it mean? It means strings are immutable. Very important concept. Please pay attention. List is a mutable object, but string is an immutable object. You cannot edit a string because if I would imagine why this is the reason, Python provided us a string data type as a way to store our names and important details about ourselves. And Python expects to keep them secure. Python does not expect that you will keep on changing your name 10 times a day, right? So yes, I try to change Nikita's name here, but Python is in support of Nikita and they are saying that you cannot change someone's name, right? So that's the best thing about Python. You can store your data if in case you have a password, you want to store a random password you want to store. You can always store that password in the string because no one can change your password without you knowing it, right? Your code remains the same. Your string will not be able to edit itself. If in case you want to make it again, you can create a copy of your own name, okay, with that edit. But the current element, the current variable does not change. Okay, with that concept, let's now look at tuples. Okay, tuples. Now, let's use the porosities list only. Or let's create a permeabilities list. My perms. Okay, let's imagine a scenario. For example, the permeability calculation has been done in a 1 crore rupee machine, which is a very costly machine. We got an access only one time to it, and we never want to touch those values calculated ever again. We want to store them in a secure place. Yes, they are a collection of numbers, but we don't want anyone to touch it. We want it to, it's like a list, but we want to keep it secure. By now, with our programming knowledge, we know that if we store in a list, someone will come up, someone notorious like that guy who, open some random things on today's session. They might come and make errors to that values of permeability, and all those costly calculations, they are all of a sudden changed, and you have lost your information. So in that case, you should store in a tuple. A tuple is always enclosed in parentheses. A list is enclosed in square brackets. A tuple is enclosed in parentheses, right? So 100 millidarcies, 200 millidarcies, 150 millidarcies, 120 millidarcies, and 50 millidarcies, right? And if you see my perms, this is a tuple. If you check the type of it, tuple, okay. My perms, you can also index it just like a list. My tuples -1. But what if the last value was wrong and the supervisor says that, hey, can you replace it with 150? Error. Tuple does not support item assignment. So I think by now you are very clear with the difference between mutability and immutability. And everyone understands the three data types: a string, a list, and a tuple. Some people call it tuple as well. I call it tuple. So are you happy with what we have discussed by now? Any doubts, anyone, before we move on to the next section? Any doubts? Let's wait 30 seconds for any doubts. If not, we move on. Okay, well enough. Let's move on then. Let's move on. The final data type that I want to discuss. Okay, there's one more data type called a set. The only benefit of a set, no one uses a set. Okay, no one uses it. The only benefit I can tell you is, so for example, my duplicate porosities. Okay? By some reason, I have duplicate values of the same porosities, like two copies of the same porosities, like this. I can do something like a set of my duplicate porosities. It gives me only the unique values. Okay, so you can use a set for unify. Okay, unify, something like that. Okay, so that's the only benefit of using a set. Let's finally move to the most important data structure, dictionary. Okay, I'll go back to the top. I gave you an example in list. Where is it? Yep, here it is. So a bag of reservoir values. You can see porosity, comma 0.23, permeability, comma 200. What if this is not the best way to store such kind of data? Rather, you can use reservoir data in a dictionary. Okay. Poro 0.23, perm 0.25, or sorry, 200. Okay. Res data. You can see now the benefit of doing this is I can easily fetch out that, hey, can you tell me the porosity of this? So you can access. You cannot index it like this. Okay, -1. You cannot do it. But the better thing is, whatever value you want you fetch, porosities, you can fetch it like this. Permeabilities, you can fetch it like this. Okay, so that's the benefit of dictionary. Dictionary is the closest you get to a tabular data. It's the closest you get. For example, not just this, but you want to add two more values to it. Okay, you want to create a list of porosities and a list of permeabilities. 0.23, 0.24, 0.25. Okay, and 200, 300, 400. Okay, and see res data perm. As simple as that. One good thing is, just to give you a slight heads up about pandas, if you import pandas as PD, you can convert the same thing to a table as well. PD.data frame, res data. You see the whole thing which you have seen here, it is prettily printed like this here. Okay, you see one error is here, which is okay. But this is how you do it. Now, because we have created an error, let's try to edit it. Okay, if I print res data, and I access porosities, and I access the first index, I want to replace it with 0.24, and I print the res data again. You can see all sorted now. Everything is good. All right. So this is how good a dictionary is. So we have seen a lot of things. We have seen a list, a tuple, a string, a lot of things. Okay. Now, let's finally look at for loops. Computer's power. Earlier, we looked at a limitation of a list where we got an error. Where is it? Yep, here it is. We tried doing the square of every element of a my porosities list. Okay, and Python said that, hey, this is problematic. You cannot do it like that. But what if you still wanted to do it? What if you still wanted to do it? The way to do it is you can iterate over every element of that list, square it, replace the element with its own initial value, and there you are. So let's create my porosities new as an empty list. Please pay attention. This is a very interesting problem. So for every porosity in the porosity is list. My porosity is list. Poro square is equals to, because now you are iterating over these values one by one. Every time you pick up a value, it's a numeric value. It's not a list anymore, because you are picking up one element at a time, and that's a number, and you can square a number, and you can append it one by one to this new list. My porosity is new dot append. Append what? Poro square. You can see you have completed that step. So you can see poro, my porosities is this, and my squared porosities, my porosity is new, is a square of every number. You can see 23 square is 529 and so on. So you can see the error can be dealt with, but the problem with this thing is it makes things very slow. It makes things very, very slow, because a list plus a for loop are the two of the slowest things in Python. Let me write it here. List plus for loop, slowest combo ever. It's almost equal to a turtle plus tortoise. Okay, so now with that being said, let's move on to the next chapter of today with data analytics tools. We will look at the first tool of today, which is NumPy. Okay, now let me introduce why NumPy came in place. But first we have to import the package. Import NumPy as NP. I like to give a very common example here. Everyone who has listened to rap music, they know Marshall Mathers, but his common name is Eminem. So it's something like import Marshall Mathers as Eminem, right? That's something very similar to what's happening here. NumPy is the original package, but you are importing it as NP. Some people call him as Slim Shady. So you can also import NumPy as capital N. It's all up to you. This thing can be anything, but NumPy has to be NumPy. You cannot be like, hey, I want to import NumPy like this. This is an error. You cannot change the original package. Just like I cannot change the original Marshall Mathers. I can use the whatever name I want to use for him, right? So import NumPy as NP is the most popular way to import NumPy. Okay, so let's use the same example. You see 5 lines of code or 4 lines of code to just square every element. But let me create something else. Poro array is np.array. This is how to create an array, okay? Because we have already created a list, we can pass that list. If we did not create a list, we could have provided the list of numbers inside np.array. That would create a one-dimensional array, okay? So Poro array, it looks something like this. So you can see here is one square bracket, which means this is a one-dimensional array. I can print the shape of this. Shape. Everyone who has read about linear algebra or matrix algebra, they know how to look at the shape of a matrix or a vector. And you can do that thing using dot shape. You can see 6 elements, so 6 comma. There is no other dimension. That's why the comma is not having any value after it. If it was 2-dimensional, it would look something like 6 comma 2. Okay. Now, if I want to square this element, if I want to square every element in the list, in the array, I can use something like this. It will not give me any error. You can see just one line of code, such a small section of code is doing what this was doing. And NumPy, let me write this down. NumPy is Flash. NumPy is built on top of C++, which is one of the fastest programming languages. And whenever you do something using NumPy, it makes your program very fast. So if you have an option to use NumPy as compared to any other way of doing things, always use NumPy. Always remember this, guys. Always remember. NumPy is like an advanced calculator in Python. You can do logarithms, you can do exponentials, you can do trigonometries, you can do anything in NumPy. You can do matrix algebra. For example, you have a matrix, you want to find the inverse of that matrix. I know back in my days in IIT ISM, the professor used to give us problem statements to solve in Excel or whatever computerized program I have. I would have loved doing it in Python if I knew it back then, right? So a lot of things about matrix inversion you can do. Dot products can be done. Whatever. If you are a mathematics freak like I am, NumPy is your best friend. You can do a whole lot of things. There's a Gaussian normal distribution. If you want to do a Laplace transform, if you want to simulate a differential equation, everything is possible in NumPy. You can go to NumPy's official website, read how you can do various things in NumPy. So if you type np dot and you press tab, you can see a whole world of things that you can do. Let's look at np.abs. It will return the absolute value. Okay. Then np.array we have already seen. Let's see some interesting things. You can see correlation coefficient, conjugate metrics, concatenate, compress, cos, hyperbolic trigonometries can also be done. Covariance can be calculated. Cumulative sum can be calculated. Diagonal elements of a matrix can be printed out. So a lot of things can be done. Okay, let's create a two-dimensional matrix. Okay, 4O 2D. How to create a two-dimensional matrix? np.array. You have to provide a list inside a list. Okay, 1, 2, 3. Okay, 0.2, 0.3, 0.25, 0.21, 0.22, 0.13. Okay, 402D. You can see this is a two-dimensional matrix. Now, if I press the shape of this, you must have guessed it, 2 cross 3, 2 rows, 3 columns. Okay, so this is how to do things. Of course, you can also square the entire thing, even it is two-dimensional or whatever dimension there is. You can multiply every element with a particular number. You can take exponential of every element like this. You can take logarithm of every element. Log base 10, let's say. Okay. So this is various things that you can do in NumPy. You can do an np.dot. Here dot product is possible. Okay. So you can see, for example, I have 1, 2, 3 as one vector and 4, 5, 6. You can see a dot product is done. 1 multiplied by 4 plus 2 multiplied by 5 plus 3 multiplied by 6. Very, very important for matrix algebra freaks. A dot product is possible, not with just 1 cross 1. We have seen people doing a dot product for million cross million matrices as well. So that can be done in like 1 second, 1 to 2 seconds. There are two very important functions that you must know about NumPy: np.linspace and np.arrange. Create your own set of numbers. Okay. So let me also, using this example, I will also introduce matplotlib as well to start introducing visualization. Matplotlib. Okay. I want you to have a quick introduction about almost everything that you will be working on when machine learning comes in. Okay. So as things go on, I will keep on introducing more and more tools, but with some context at least. So for example, everyone has seen a relative permeability plot. On the x-axis, you have water saturation, which is an array starting from 0 up to 1 in fractions. Okay. So what if you wanted to create hundreds of such parameters within a given range? So the way to do that is SW is equals to np.arrange. Press shift plus tab inside it. You can see it asks for starting number, stopping number, and step. So you can provide 0, 1 as the stopping number, but 1 will not be included. So you provide 0.01, 1 plus 0.01. And let's provide the step as step as 0.01. Okay, so you can see SW is so many values are created. The delta X is 0.01. Okay, now I can calculate relative permeabilities for water and oil using this. KRW is equals to, let's say, SW to the power 3, and KRO is equals to 1 minus SW to the power 2. Okay, now let's visualize this plot to make it look something that we have seen in the textbooks. Import matplotlib dot pyplot. Matplotlib comes from MATLAB, to be honest, and it has a Python plotting sensation for it as well, and that is called pyplot. But you always have to import something like this. Import matplotlib dot pyplot as PLT. All you want to do now is you want to plot KRW versus SW and KRO versus SO on the same plot. Okay, PLT dot plot. SW is the x-axis. So basically the syntax when plotting anything is PLT dot plot x comma y. Okay, so let's do PLT dot plot SW comma KRW. There you go. On the same axis, if I want to plot PLT dot plot oil rel perm as well, SW comma KRO, and see oil rel perm as well. But who knows which is which? This is your very important visualization session, guys. Please focus on this. I will add many layers of customizations to this plot, and that will be the most exhaustive customization that you will ever do. So if you pay attention to this level of visualization, you will rarely do something else. Okay, basic visualizations will be covered like 80 to 90% of the cases. This is what you will be using. Okay, so for example, if I want to add a grid, plt.grid is the command, plt.grid. Okay, so we also have a grid now. What if I wanted to provide a label for each plot so that the user can recognize, so that I can add a legend to this plot, just like MS Excel provides us. So I can provide a label to it. Label, this is water rel perm. And similarly, you can add a label here as well. Oil rel perm. Okay, and when I do this, you see there is no difference created because we need to provide one more thing here, plt.legend. See, now we can directly see that as water saturation is increasing, water permeability is increasing, water rel perm, and oil rel perm is decreasing. Okay, very important concept. But we still have to add X labels, Y labels. To do that, plt.x label SW in fraction, plt.y label A rel in fraction, KRW, whatever you want to write. Okay, KRO. You can see now I have X label and Y label as well. Now I can increase the thickness of these lines of the plot, make it better and more visible. Line width LW equals to 3. Similarly, LW equals to 3. You can see now it's looking much more better. Final touch we can provide it by providing it a title. plt.title. My first two-phase rel perm plot. You can see my title is here. So you can see what we started from was a very basic plot, but what we have now is a brilliant plot. Okay, we can add, if you don't want a grid, you can provide a comment like this. You can remove a grid block, and you can do all sorts of things. So we started with the NumPy array. We did some calculations on the NumPy array. We looked at how to create a list of saturations using np.arrange. What if someone told me that, what if I did not want to provide delta X, but I want to control the number of X values I want, right? So that you can use np.linspace. Start at something, end at something, and provide 100 values of that range. They are doing basically the same thing. Either you provide me the range and the number of values, I can calculate delta x on my own, or you provide me the range and delta x, I can calculate number of values on my own. They are just two commands that do the same thing, depending on what you want to control, depending on if you have a delta x with you or you have a number of values with you. You can see if I do this, the same thing is happening. Okay? The difference can be seen here. If I print only 10 elements, the smoothness of the plot is going away. You can see some edges are created. So if I reduce it to 5, you can see the smoothness of the plot is going away. So as the number of values are increasing, 500, you can see 500 elements. We are dealing with 500. Let's increase it to 5,000. So fast. Still 50,000. Still so fast. 500,000. Now it's taking, but still 3 to 4 seconds, you could deal with 500,000. Let's add 5 million data points. It's taking time now. Finally, we are reaching there. But it will still complete the entire thing in let's say, I'm hoping it will complete it within 1 minute. But it will complete it. If it could not do it, it would have directly given me a memory error. But right now it is calculating all of it. You can see it did it within 30 seconds. 5 million data points. Okay. So you could add one more zero, but we don't have much time, right? So this is how things happen in NumPy, very fast. So this was all about NumPy. Other things about slicing a NumPy array, indexing, etc. Everything can be done similar to a list. But the major difference that I wanted to tell you is NumPy is flash. You can do computations in a single line of code. There are various math options available in NumPy, and you don't have to use for loops in NumPy. Okay, and you can add plottings to further your NumPy calculations. So we looked at NumPy as well. We looked at a bit of visualizations as well. What if you want to generate random numbers using NumPy? Random number generation in NumPy. Okay. The way to do that is you can use this np.random.normal. So basically, the idea behind random number generation is you have to specify what bucket of numbers are you picking up random numbers from. What is random number generation? It's a way of sampling. For the students of probability, you know sampling with replacement, sampling without replacement. Everyone knows about that, right? If you replace something without replacement, then it is not an independent event. But if you sample with replacement, it is an independent event. So that's a different topic. That's probability, but random number generation is sampling only. You have to tell Python that, hey, Python, can you fetch that particular number bucket, and from that bucket, can you pull out 500 numbers from me? That's what is happening. So right now I'm telling you this bucket name here. I'm asking Python to pick up the normal distribution of numbers, and from that bucket, pick up size equals to 100. Okay? And what if I want to verify that this is from that normal distribution only? I can use Seaborn for this. Import Seaborn as SNS. Remember, guys, Matplotlib and Seaborn, they have almost equal superpowers. But my aim with this session was to give you a feel of all the possible packages there are, and that's what I'm doing. So when I import Seaborn as SNS, SNS.diskplot is a way to show a distribution of numbers. So if I'm fetching these numbers here and I plot them as a distribution, you can see it's looking like a bell-shaped curve, which is exactly what normal distribution is. If I increase the number of samples, the plot will get closer and closer and more symmetric, looking like an actual normal distribution. If I sample more, you can see now it's almost looking at an exact normal distribution, perfect normal distribution. So this is how you generate random numbers and show the distribution in Python. Okay. Given we are almost there at the top of the hour, we should now conclude with Pandas. Okay, Pandas. What is Pandas, guys? Not the animal. It's the Excel of Python. It's for tabular data. Okay. Let's create some data. Let me see if I have some data with me. Let me fetch some data for you guys. Let me see. Just give me 1 minute. I'm trying to fetch original production data sets so that I can tell you how to work with Pandas. Okay. So just give me 1 minute. I'm opening my GitHub repository. I'll copy paste the link with you in the chat. You can refer that. But my aim is to, okay, let me use some well-testing data set. Okay. Well-testing data set. I have the data set with me. Control C. Okay. So DF, pressure versus time. Okay. Pressure versus time data set. So first you have to import Pandas as PD. Okay. There is this data set path that I have copied from somewhere in my GitHub repository. Okay. And I will import this data set inside my Python environment in PD dot. The way to do that is, because you see the extension is CSV, it's a comma separated value file. And we are trying to read it. PD.read CSV, you will provide a dataset path here. You can see time versus pressure data is here, and you can store it in a variable called df. Okay. Now, df.describe is the first thing that you can do in Pandas. The reason or the thing that df.describe does is it prints in front of you for every column in the data set. It will print out descriptive statistics for you. What are descriptive statistics? Things like mean, median, 50th percentile, 25th percentile, 75th percentile, minimum, maximum. So it's an important information indicator about the entire data set. It's like a quick sight of the entire data set. For example, if you have oil production data set, you can import that data set and you can see what is the common range of oil production values. What is the common range of choke size values? What is the maximum rate of water injection happening in the field? What is the maximum pressure of the reservoir? Maybe that's the value of reservoir pressure, theoretical reservoir pressure. So all these informations can be gathered, but the way to do that is to use df.describe. You can see this is a very simple data set, so these values will not make any sense. You can see the count, which is we have 78 values, the average, which is mean, standard deviation, minimum, 25th, 50th, 75th, maximum. Okay, so we have imported a data set. We can also create our own data set, my own. So suppose my own data set, okay? And I already told you, I already told you that, right? We can create our own data set. Let me copy that again. When I was discussing dictionaries, yep, here it is. I can convert a dictionary to a data set using this command. Okay, so you can either create your own data set, but that's very rare because this is not data science. If you are working in the data science industry, you might already have some data which you have to process. So this is a better example, importing a data set by the provided path. Okay, so you have provided the path, you are reading the CSV file, you are storing it in a data frame, you are first looking at it. You can also do a df.plot, okay, and provide a fixed size equals to 12 horizontal size and 4 vertical size. You can see all the columns are printed along with the number of rows. Does not make sense. I know this plot does not make sense, but you can use Pandas to generate your own plots as well. But everyone who has studied well testing, they must be wanting to see whether this is a pressure drawdown example That is, whether pressure depletes with time or is it a build-up test. By looking at it, you might be feeling 2743, 2737. It might be a drawdown test, but let's look at it, okay? So the way to fetch columns is accessing data in data frame. What if I want to fetch a time column only? Okay, time column. The way to do that is provide the data frame name, provide a square bracket, and provide the value of the column name. Okay, so you can see time column. Time column is here. Can you please mute? Okay, time column is here. Similarly, you can fetch the pressure column. PF pressure column. So this is the way to access columns in the data set. Okay, but what if you wanted to accessing columns is simple and easy? Very similar to a dictionary. Okay, accessing columns. But columns have their header names. That's why it is so easy. But the rows, they don't have any names. So accessing rows. We can use iloc. Okay. So what if I wanted to print the first column, which is at the 0th index and top 5 rows? So I can use df.iloc. Starting at the 0th row, I want to print up to the 5th row, and starting at the 0th column, I want to end at the 0th, which means I want to only print the 0th column. You can see 0, 1, 2, 3, 4. Okay, this is not the way to do it. You have to provide one element at least. Start at 0, end at 0 does not make sense for Python. So you can see the first 5 rows are printed for the first column only. But what if I wanted to print all the columns? You can see first 5 rows for both columns are printed. So remember guys, it's like a 2-dimensional array. The first thing before the column is accessing the rows, and the second is accessing the columns. You can imagine it similar to being a NumPy array in both the dimensions. This is to access the NumPy array in the y dimension. This is to access the NumPy array in the x dimension. What is the array in the x dimension? It is the column headers. What is the array in the y dimension? It is the row numbers. So this is, if I add 10 here, it will fetch the first 10 rows. You can see indexing is starting at 0. If you print up -1 here, it will print up the pressure column and the first 10 rows. You can see. Okay, so this is how you do it in accessing all the data in Python in a tabular format. If you want to print all the data, you can just provide a column like this and column like this. You can see the entire data set is printed. Okay, let's visualize finally plt.plot. What is the x? In well testing, what is the x? Time is the x-axis. And what is on y-axis? Pressure is on the y-axis. You can see pressure is depleting with time, which is again a very good example of well-test analysis. But sometimes you might want to see the pressure plotted as along with logarithm of time. So let's do that. Let's create np.log of time and df.pressure. You can see a semi-log plot is created. Someone who has read a lot of reservoir engineering might be already thinking which is the middle time region in this plot, which is the best straight line that I can pick up. Maybe this, maybe this. For that, you might have to do log analysis. So if you want to do something like that, there are codes on my GitHub repository. You can check that out. But the aim here is not this. Now, what if I did not want to do this much calculation? What if I want to create new columns in the entire data set only? Okay. Creating.
Divyanshu, before you move further, like, yeah, can you like scroll a little bit up?
Sure.
Where you accessed this from your GitHub, right? From your website, you put it in HTML to access it.
Yep.
If I'm having a file on my local desktop or maybe in C drive, how
Okay.
would I access that Excel?
Sure. So let's do that. And that will allow me to introduce one more thing. Okay. So df dot to CSV. What I'm doing here is I'm fetching this data. I've fetched that data from cloud. Okay. So what if I wanted to store it in my local with a particular name, my well test data dot CSV. Okay. If I press this command, it will store this data in the local directory wherever your code notebook is located right now. In the same folder, this data set will be stored. Okay. Now, if I comment this out and I do the pd.read CSV again, and I just press tab, if I just press tab, you'll see a list of values, right? You'll see a list of values in your current folder. Okay. If you don't want to do it like that, what you can do is you can, now this is a bit advanced for most people, but you can import OS library and you can print os.list dir. You can see it prints out all the elements, all the files that are stored in the current folder. So in my current folder, I have this notebook which I have opened in front of you, and I have this well test data. So I can copy this here and I can paste this here. There you go. There'll be some problems because when Python stores the data, the index is also stored as a separate column. So you might want to say that, hey, ignore the index by doing something like this. Index column equals to 0. You can see again, we have imported this time from local. But then you will ask me, what if my file path is not this simple? What if my file is located somewhere else in my computer? For example, what I can do is I can go to that file in my computer, right click on it, copy the path of that file, paste the path in place of this entire thing. Okay, that's as simple. So it's a bit of practice that you might need to do. By OS package helps you do that without, if you don't want to go to the file path manually, you can use OS package to navigate yourself to that path, copy that path, paste it here, import it. Okay, so I would advise you to go back and check about the OS package. It's one of the most brilliant packages to have practice on, because it makes you more automated. You don't have to do things manually. For example, I did not have to go and check what was my file name. I could directly copy it from here, right? So that is something that you can do. Okay, I hope I answered your question.
Yeah, thanks, Divyanshu. Thanks.
Yep, you're welcome.
So
Okay.
by this
Yeah,
means I can access any Excel from my file, and I can literally just do any function, any formula writing on that Excel on any column,
absolutely.
right?
You can fetch that data from any part of your computer, apply some computations, and store it back with the updated name. Okay, you can do these iterations every day. You can keep on iterating and improving your data, right? So that's possible. So if I wanted to, like, I have stored this well test CSV here in this particular format, right? What if I wanted to create one more column, log of time, and that will be np.log of the original time column. If I look at the first 5 rows of my data, and see, now I have the log of time. Now I can store the data set with a different name, well test log time.csv. Now when I import it, again, pd.read csv. When I import it, I will provide this path only. I need to tell Python index 0 because we just saw the problem. So you can see the same data that we created here is now imported. So you can store it as df new. And we can do the same semilog plot, plt.plot, df new, log of time versus versus df new, pressure. What happened? Okay, sorry, pressure. So you can see the same plot. I created another column called log time because I want my code to be more readable and less command related, right? So that's about it. I think you can carry on with this entire workflow and do some, like I can write it here as well. Carry on with it and do the log analysis on this well test data. I mean, if you do it before the next time we meet, I can assure you that you have had great hands-on work with all the tools we discussed today. So, I mean, this is a good practice to benchmark your progress. Okay. So if in case you do this, very, very good. All right. So one final thing before we just hop off, I think we are over time, but just to compensate for the time that we lost, is to tell you about functions in Python. Functions in Python. For example, I have a quadratic equation like this. Equation like this. 5x squared plus 4x plus 3. Okay, quadratic expression, not an equation, but an expression. Okay, what if I wanted to have a function in which I could just input x, get the value based on this quadratic expression? I don't want anything to leak. I don't want to reveal this formula. This is a formula I have calculated as a part of my research. I don't want to leak the formula to the world. I just want to show the world this function that I've created. So I can create def rocket science expression. I can create a function like this, okay? Let me give you a first very simple example. What if you want to create a function for squaring a number? Squarer n, return n squared. Okay? So this is called function definition. And then what I can do is squarer 2, it returns 4. The benefit of this thing is I can go 100 lines below. Wherever I'm in the code, I don't need to write that entire function again. I can just use squarer and I can provide 50. It gives me 2500. So the user does not have to see what was inside. The user just has an input-output kind of thing. The user just has this interface. This is called code abstraction. That's a great superpower to have. Suppose there are 10 steps of something. For example, you have created a coning algorithm, water coning algorithm. For example, you have created a baudit analysis algorithm. 10 lines of code, you want to keep them in a function. You don't want to show that algorithm to the world. You can store them in a function and use a simpler name, my well test function. Ask the user to provide the pressure and time data and return the permeability. That's it. Why does the user have to see the entire algorithm? It makes it simple for you as well. It reduces the number of lines that you want to use. Okay, so going back to the quadratic expression, the input here is x. There can be multiple inputs as well. And return statement is what? 5 multiplied by x to the power 2 plus 4 multiplied by x plus 3. Okay, so rocket science expression can be called on 1000. Okay, so this is about functions. I mean, many more customizations are possible, but this is the very important basics about functions. So that concludes our today's session. Hope you learned something from it. We will meet next up with great machine learning algorithms. I'll talk to you on whiteboard. I'll explain the algorithms, and then we will do some project as well. Okay. So that's it. This notebook will be shared with you. Any doubts, anyone? Not audible? Was I not audible? I think.
Sir, hello.
No, sir, it's fine.
Sir, I have a doubt.
Yeah, Shashwat, go ahead.
If we save a file like a CSV here, so it gets saved into same directly.
Yep.
So what if we are using Google Colab? So where it will be saved?
So in Google Colab, in the left, you will see a folder, data folder. I don't remember, but in the left, there will be a set of folders. So it gets stored in one of that folder. So if you just scroll around and you will find your file where it is stored. And if you want to import it, there'll be 3 dots on the side of it. You can copy the path of that file. So I don't remember in Collab. I think it's data folder only. I think on the left panel you can find that folder.
Okay, sir, I will see.
Okay. You can also Google search on how to connect your Google Drive with Google Colab. Okay. So that's a good way to do things, because you can store data in your Google Drive and import that data inside your notebook.
Okay, sir. Yeah. Thank you.
Okay. Any doubts, anyone? Please do mark your attendance shared in the link, because I think that's how certifications will be provided.
Divyanshu, one thing from my side.
Sure.
Like, can we do something as complex as importing two Excels together and comparing cells and seeing if both the cells are like, right, a basic VLOOKUP formula, and
Yep.
just putting the same concept, same algorithm, and comparing whether the two cells are having the same values, if not overwriting the new cell value, the new Excel cell value into the old cell value. That also can be done using this
Yep. Absolutely.
NumPy Panda.
Pandas, the pseudo code can be, step 1 is to import df1 and df2. Okay. A VLOOKUP is something like you have a common key column and you want to look up all the values in another table based on that key column, primary key,
Something like that I want to work on.
Yeah.
Something like that, that
Yep.
I have the well name, I have the well API,
Right.
and I want to compare whether the start date, end date, like everything is same or not. Something I have in mind.
Yeah,
So if
I'll
I'm
tell you.
using it,
Yeah. So just create the common column in both the tables. Okay. Import it in Pandas first up. Create, suppose there's a column key, which is a combination of well name underscore API, something like that, whatever. Okay. And that column name will be there in both the tables, I'm assuming. Okay. So now what you can do, you have a common column name in both the tables. Then you can join, you can keep one table as the base table. For example, if you have a production well parameters in one table, you can keep that as the left table and join the right table on that particular column. Do the left join. You can Google search how to do a left join in Pandas. Okay. So that's the easiest way, and it's even faster when you do it in Pandas. So I personally like doing things in Python, even if Excel option is available, because that allows me to create an automated code. I don't have to press buttons every time, right? So you can search about left join on a particular column.
yeah, that's what I want to implement currently.
Yep.
I want to make an automated code towards what I am executing on a daily basis.
Yep.
So that's why I wanted to get a hands-on experience on this. Thanks, Himanshu.
Yep.
Thank you.
Very easy to do that. Yep. No problems. Any other doubts?
Looks like we don't have any doubt anymore, sir.
Okay.
Thank you, sir. It was a very insightful session and a lot of awesome information and educative stuff delivered in such a time efficient manner. So we will meet you in the next session. And for everyone present, if you want to catch up again, we'll try to provide the YouTube video as soon as possible and try to catch up, revise stuff, and explore a bit from your side before the next session. See you guys next time. Okay. Thank you, sir, again for this awesome session.
Thank you. Have a good weekend. Bye.
Okay. Thank you.